Check. In this video, I'm going to find the general solution of the ODE y prime prime plus y prime minus 2y is equals to 0. What we are given there is a second order ODE with constant coefficients. It is of the form a2 multiplied by y prime prime plus a1 multiplied by y prime plus a0 multiplied by y is equals to 0. To solve equations of this form, we have to find the auxiliary equation first. The auxiliary equation is of the form a2 multiplied by m squared plus a1 multiplied by m plus a0 is equals to 0. We then go on and find the roots of the auxiliary equation. If the auxiliary equation has real distinct roots, m1 not equals to m2, then the general solution is c1 exponent of m1x plus c2 exponent of m2x. If the auxiliary equation has real repeated roots, m1 equals to m2 equals to an m, the general solution is c1 plus c2 multiplied by x multiplied by exponent of mx. If the auxiliary equation has complex conjugate roots, m equals to a plus or minus ib, the general solution is exponent of ax multiplied by c1 sine of bx plus c2 cosine of bx. Now if we compare this equation that we are given to the general form of a second order ODE with constant coefficients, we see that by comparison there, a2 is equals to 1, a1 is equals to 1, a0 is equals to minus 2. So substitute these values into this auxiliary equation that we have here, and we have our auxiliary equation will be m squared plus m minus 2 is equals to 0. Try to factorize this equation here. Look for numbers which when you multiply them, they give us a minus 2. When we add them, they give us a 1. Those numbers are minus 1 and 2. So our equation becomes m minus 1 multiplied by m plus 2 is equals to 0. Solving for m there, we see that our m1 is equals to 1, our m2 is equals to minus 2. So what we are having there is we are having real distinct roots. So our solution is of this form here. So where we have the m1 here, we are putting 1. Where we have m2, we put minus 2. So our general solution will be y is equals to c1 exponent of x plus c2 exponent of minus 2x. Here I'm writing y of x just to denote that y is a function of x.